I'll I'll send a recording of yesterday's and today's today. All right. So the concept I under or on rotation says that whenever mirror mirror is rotated, whenever mirror is rotated, the angle between the reflected rays, because the old position of the mirror will give you a reflection R, and the new position as a result of the rotation would also give you a reflection R. So the angle between the reflected rays is always twice the angle of rotation. So if you rotate the mirror x degrees, the angle between the reflected rays would also be 2 times x. That is the concept. That is the concept. So here we are assuming, let's assume the angle is alpha. And it means that if the angle between the reflected rays is alpha, then Ishra, what can you say? If the angle of rotation is theta and the angle between the reflected rays is alpha, what equation can you write, Ishra?
And alpha is equal to 2 theta.
Exactly. In exams, sometimes what we do is that we can give you the angle of rotation. You need the angle of the angle between the reflected rays, okay, for calculation. An example of what we often do is that an incident, a ray incident on a plane mirror. The mirror is rotated. Okay, so this is the mirror. A ray incident on it. Once it's incident on the distance, it will give a reflection on a screen. Then sometimes the height, once it's incident on the screen, it will form maybe an image on the screen. The mirror is rotated. An image. Don't forget that reflected rays form the image. Okay, the image of the source is captured on the screen at a height, maybe so and so after rotation. After the rotation. Okay. Now the question is that find the height. Okay. Find the height of the image form. This is the image form. The first reflection produced the spot. Okay, or let's not even call it image. The first one produces spot S1. The second one also produces spot S2. Okay, the question is that find the height or the distance between the two spots formed by the mirror after rotation. So this is exactly what they are looking for. Is Lawrence, are you back? Now,
Yes, please.
okay. Now, in determining this, you will need the angle between the two reflected rays. And that is where you apply this concept. That you know that when the mirror is rotated through an angle theta, the angle between the reflected rays will be twice this. So if the question gave you this, maybe 15, by this concept, you understand that, oh, the angle between the two reflected rays will be 30. Okay, then knowing one of them, the information would give you a detailed, okay, the question will give you a detailed information to do that. Knowing one of the sides, knowing the angle, you can easily calculate the distance between the two spots, S1 and S2. Please, are we there?
Mr. Teacher, please can you go over?
All right, I'll go over. Another situation. Light is incidented on a mirror. This is the initial position. Then maybe you are told that, yeah, there is a screen. The reflection is would incident and reflect on a screen. So we are assuming the reflection is this. So there's a spot created on the screen. On the screen. Now this thing is rotated. The mirror is rotated through an angle theta. Is Gloria here?
Yes, please.
Okay. The mirror is rotated through an angle theta. When you rotate it, you are not changing the position of the source. You know its reflection will be different. So the reflection of this, maybe, so there's the first spot, maybe there's the second spot on the screen. So S1, S2. You are asked to determine the distance between the two spots, S1 and 2. Okay. Some other information can be given to you. I'll look out for a question that applies this, okay, and then just solve it with you or give it to you to try, then we look at it. But all that you need is that to get this distance, you need this angle, isn't it? And this is the angle between
Yes, please.
this is the angle between the two reflected rays. And that is what we are saying, that when you rotate a mirror, the angle between the reflected rays is always twice the angle of rotation. So if the angle of rotation is given to you as theta, then it means that the angle between this and this would be twice theta. You are there. Knowing one of these two, or any detailed information, you can easily calculate for the distance between the spots. So this is how we apply the concept of rotation of a mirror in questions. You would have to understand that when you rotate a mirror through an angle theta, the angle between the reflected rays is always twice the angle of rotation. That's all. The rest are trigonometry, because they'll give you sometimes it can be the first spot, oh, the first incident ray hit on the screen horizontal to it, and it's here. Then the second one, after the mirror being rotated, the reflection is this. If this is perpendicular to this, and the second spot is this, calculate, this is S1. Calculate the distance between the two spots, S1 and S2. Okay, Since this is reflected ray, you know that this angle is twice theta. So knowing this angle, knowing this distance, they can give you a distance so and so from this point to the screen. So if you have this distance x and you are asked to find this, can't you use trigonometry to easily calculate that? Hello, can't you? Are you there?
Yes, please.
So that's the application thing I'm talking about. I'll look for questions, give it to you to try, and you realize that this rotational thing is not difficult. Let me go over the rotation of mirror and then how we derive this the last time too, for the benefit of those who are not clear or those who just joined us. Okay. Okay, so everybody's here. Okay.
Yeah.
Hello.
Please, are you going over again?
Yes. Yes.
Okay.
So the concept of rotation of a mirror. I have a mirror positioned as this. I have a source of light. It can be from the sun or any fixed light incident on the mirror. So there is a source. Once there is a ray hitting the screen, there will be reflection. Incident ray, reflected ray, all at the same point, at the point of incidence. A normal perpendicular or a line perpendicular to the plane gives us the normal. So this is a normal mean. The angle between the incident ray and then the normal angle of incidence. Angle between the reflected ray and the normal angle of reflection, which is R. But we know R is equal to I. Angle of incidence equals angle of reflection. So we can actually clear this and call this I as well. Equally, we can decide to bring R, clear this and call it as R. The value is the same because I is equal to R. Are we okay?
Yes,
Now,
please.
Yes, please.
the mirror is rotated clockwise. This is not a different mirror, the same mirror. But now it's like holding it and then turning it after giving you this information. So this is the old position of the mirror and then the new position. The angle of rotation is theta. We are not changing the position of the source of light. If it's the sun, you cannot go and then tilt the sun just because you have tilted your mirror. So the source of light position is intact, meaning that the incident ray is still what it is. Laurentia, Irene, are you okay?
Yes.
Okay. Now, once the mirror is rotated, it will give us a different normal, because the normal, whichever position of the mirror, should be always be perpendicular to the mirror. So once you rotate it through an angle theta, this normal with the normal with respect to this new the new position would also change, because normal is always perpendicular to the mirror. So once it is rotated, the new normal must be here. And we are calling the new normal as n prime. Please, if you haven't muted,
Mr.
please
Joa,
for me. Laurentia, I'm listening.
Stadia, please, it was not me.
Okay. Please, if you haven't muted, okay, I'm getting a bad feedback. Okay, so now once this is being rotated and then the normal position is changed, there will also be a different angle, incident ray. You have tilted the mirror. The incident ray is, but the reflection will change, because always the angle of incidence between the new normal and then the incident ray must be equal to the angle of reflection. So if this is the extent of angle at the angle between the incident ray and the new normal, then we should get the same extent as the angle of reflection somewhere here. So I have to get a reflected ray equal as, I have to get angle of incidence equal as, let me say incidence, angle of reflection equal as the angle of incidence. So this is the old reflected ray, and this will be the new reflected ray R prime. So from here, incident ray to the old normal, the new normal must be equal to the angle between the new normal and the new reflected ray. Are we okay? Irene, Laurentia, are you okay?
yes.
All right. Now, let's look at the angle between the two normal. How would that be? Let me use something small to help you. This is, I'm trying to get a smaller something which will not take much space. I have this. This is the old position of the mirror. The pencil represents its normal. Okay. I'm rotating the mirror, and look at what will happen to the normal. Please mute. If you haven't muted, do so for me. Okay, so this is the original position of the mirror, and then the normal to it. I'm rotating the mirror through an angle theta. Look at what happened. As I rotate the mirror, the normal also changes. So you rotate the mirror through an angle theta. The normal is also rotated through the same angle. And so we conclude that if you rotate the mirror by an angle theta, then the angle between the old normal and the new normal would also be equal to the angle of rotation theta, because they go together. Irene and Lorisha, are you okay?
Yes, please.
Good. So if this is theta, the angle between this and this would also be theta, because they move together. Now let's find the angle between the incident ray and n prime, which is the new normal. What do you think will be the angle? The angle, this whole angle, the new angle of incidence. Okay, this whole angle is made up of this angle plus this angle. So if this is I and this is theta, then the whole angle must be equal to I plus theta. Okay, meaning that the angle between n prime, the new reflected ray must also be I plus theta, because angle of incidence must be equal to angle of reflection. Are we fine?
Yes, please.
Good. So I know angle n prime O r prime, which is this bigger picture, must be equal to I plus theta. Let me clear this from here. All that I'm looking for is this angle, the angle between the two reflected rays. The angle, this is the first reflection, this is the second reflection. I'm looking for this angle, which I don't know. But what I know is that this, the angle of reflection, n prime O r prime, is equal to this small angle plus the angle I'm looking for. Okay, this bigger angle is equal to this plus this. So angle n prime O r plus angle r O r prime. Meaning that if this is what I'm looking for, then I just would have to make this the subject. Angle r O r prime must be equal to angle n prime O r prime minus angle n prime O r. I'm just making this as a subject. Okay. Now, fortunately for me, I know angle n prime O r, which is this. So I plus theta, but I don't know this. I don't know angle n prime O r, n prime O r, which is this small angle. I don't know. Are you following?
Yes.
Then I have to find, but at least I know the angle between, I know this angle, N O R, this angle, I have an idea because that's the old angle of reflection when the mirror is not rotated. And with that, we said, because we said I is equal to R, this gives me the answer that, oh, then NOR will certainly be equal to I. Okay, So NOR is I. So if this whole angle, okay, if this is I and this angle is theta, I can easily find this small angle, isn't it? The whole
Yes,
angle
please.
NOR is I, and angle NON prime is theta. Then I can easily find angle N prime OR. Therefore, angle N prime OR would be equal to angle NOR minus angle angle NON prime. And this is equal to I minus theta. This is equal to I minus theta. So I can substitute this into this equation because I have this to find the angle between the reflected rays. So angle ROR prime is therefore equal to I plus theta minus I minus theta. Okay, the road is now straight for me to determine whatever I'm asked to. So if ROR prime is equal to I plus theta minus I minus plus theta, giving me this and this cancel out 0, and this plus this will give me 2 theta, confirming that whenever a mirror is rotated, the angle between the reflected rays, okay, before and after rotation is always equal to 2 times the angle of rotation of the mirror. So when you rotate the mirror by theta, the angle between the reflected rays is twice this angle. Okay, hence what I gave you. Whenever mirror is rotated, the angle between the reflected rays is always twice the angle of rotation. Okay, so that is the concept of rotation of mirror. The practical application is that if a question gives you this as maybe 15 degrees, then it means the angle between the two reflected rays will be twice this value, which will be 30 degrees. And I was telling you about how we often apply this in questions. That a ray incident on a mirror and then produces a spot on a screen. So here, this is the screen. Once it's a screen and there is a spot, that means that a real image will be formed on the screen. So this reflects, producing a spot on the screen. Don't forget, this is the incident, this is the reflected ray, meaning the source is here. Now the mirror is rotated through an angle theta. It's rotated in a clockwise or can be anti-clockwise. So there is a mirror rotated through an angle theta. So angle of rotation theta. Okay, after we are not changing the angle of the incident ray, it's still what it is. But we are told that this produces a reflection or produce a spot on the screen at maybe a distance so and so from the mirror. See, and for sometimes this is given at a distance so and so from the mirror. So from this point to the screen, this distance can be given. So this is the spot created by the new reflected ray. So these are the two reflected rays, this one and this one. Okay, this one producing the spots here. This one also producing a spot. So S1. This is S2. This is S1. Okay. Now the question is that determine the height of the image formed on the screen. And this is the image formed. Okay. So this determines the height of the image. Don't forget this image is perpendicular to the reflected ray. Okay. But you need this angle. You need this angle. Determining this angle is what we've done. That whenever a mirror is rotated, okay, the angle between the two reflected rays produced is twice the angle of rotation. So if this is given to you as theta, then it means this will also be 2 theta. In numerical sense, if this is maybe 15 degree, then this will also be 2 times 15, 30. Having this and having given the distance of the second image from the screen, maybe 12, you can easily calculate for the height of the image formed. Please, is that okay? Is that
Yes,
okay? So this is
Yes.
how we apply the concept of rotation of mirrors. And sometimes this angle can be the angle of rotation will not be given. This will be given. The angle between the image or the reflected rays is so and so. It's alpha. Calculate the angle through which the mirror is rotated. Then you are sitting down. When you know the angle between this is always twice that. So let's assume this is beta or theta. Okay, you know that this angle alpha is always twice theta. So if you are given this to determine this, just make theta the standard alpha over 2 and we'll call bed. That's it. So the concept isn't difficult, so is the application. I'll look for similar questions on this and then just give it to you for the week. All right. Okay. Do I clean the board? Yes. Hey, today you are not talking, no. Injira, Trifina, you are all quiet. Is it because of the weather or you girls are eating?
Sorry.
Yeah, maybe you are eating or sleeping. Okay, so we are through with formation of images in everything about plane mirrors. Okay, what are the uses of plane mirror? What are the uses? Yes, everybody should give me one. Starting from editor. Editor, give me one use of plane mirror. Editor, are you there?
Yes,
Then
please.
Gloria. No, let's not waste time. One usage of plane mirror. Quick one.
Please, they are used in mirror periscopes.
Mirror periscope. Gloria. I'm sure somebody will not get anything to tell by the time I get to her. Hey, Gloria. Hey, Gloria, are you there? Gloria and her audio. Okay, Irene.
Stadia.
Gloria, let's not waste time, please. Okay, Gloria.
Please, they are used in some instruments, like some scientific instruments.
Which instrument is that?
Um, um,
I get you. It is reflecting telescope.
I was going to say telescope, but I wasn't sure.
Okay. Then Irene, over to you. I hope you are writing. Yeah, use that one.
Looking glass.
Looking glass.
Yes.
How is looking looking glass like?
Yes. Let me change it. They are
Uh-huh.
used in solar focus.
Okay, okay, I'll buy this. Then
I should
let
say
me get
another one.
that's okay. Okay, Janisha, over to you. Speak up. Your voice is faint.
They are used in flashlight.
Flashlight. Which flashlight? Let me know better. Explain further. Which flashlight? Okay, Laurentia, over to you. Laurentia. Okay, Injira.